So far, we've used limit laws and a little bit of algebra to find limits at a finite point. We also talked a little bit about asymptotes and whether something is going to infinity or negative infinity. We didn't talk that much about it. We'll look at that a little bit more today as well. But for now, I want to do some discussion about taking the limit to infinity or to negative infinity. So we did have discussion about horizontal asymptotes and all of that just from a point of view of looking at the graph. Now we're going to learn how to compute those limits. All right. And I know you've already seen some of this in pre-calc, sort of the long-term behavior, the long-time behavior, or the large X behavior, however you want to call it, of polynomials, of rational functions. So this is just building on that, but giving it a little bit of more of a stronger basis, okay? So in our case here, when we're talking about rational functions and polynomials, what we're going to be using are sort of the observations that I have behind me, okay? So for example, very importantly, these two, right? If I'm thinking of x, 1 over x to the r, whether I'm going to positive infinity or negative infinity, both of those are going to go to 0. And by the way, I'm taking r is a rational number, so it could be a square root, it could be a fraction, whatever, or it could just be a natural number. But in any case, it's positive. So we have something in the bottom. So any of these kinds of, obviously any of these, it's going to look something like this. It might look like that, or it might look like that. But in any case, as I go out to infinity, and we can prove this, but as I go out to infinity, this is just staying as 1. This is getting very, very large, so the whole thing is going to go to 0. Now, if instead I look at polynomials, right, I'm not going 1 over infinity, I'm just going out to infinity. So I'm going to have something that's growing without bound. Now, if I just have a polynomial, my question is it growing without bound positively or negatively? And what you can do is you can certainly, in this case, we're just looking at a monomial. But for polynomial, it's going to be the leading term that drives it. But in any case, for the monomial, if I have something with an even power, then I've got something that looks like x squared, x to the 4th, x to the 6th. So this is going to be doing this. Whether I go off to the positive side or to the negative side, it's going to be going off to infinity. However, if I have an odd power, I'm going to positive infinity on the right and negative infinity on the left. So that's going to be something like this. And so just building off of that, you can then kind of imagine that if I have a polynomial with a number of terms, obviously as I get very large, the biggest term is going to take over. In the middle, you may have a bunch of different wiggles and stuff, but at the long time behavior, or a big X behavior, on the positive or the negative, it's going to go by the power of the biggest term, basically. Okay, so just kind of keeping those in mind as we go over more complicated ones. I know that, so let's take a look at an example of a rational function and what's going to happen as I go out to infinity. So probably in pre-calc, you guys talked about asymptotes and you learned the rules for how to figure those out, right? So if I have a problem like this, whatever, something, right? So there are rules which you've learned, take the ratio of the coefficients, whatever. In this class, we're going to be doing the limit algebraically. We're not going to just be using those, oh, I learned the rule in pre-calc that it's this. We're going to show why it's that. So I do want to see your work, even though you may know the answer simply from what you learned before. I do want to see your work. So that's one thing I wanted to say. Second thing I wanted to say about this is, okay, I'm going to go through this procedure, but the question is, why can't I just use the limit laws, right? This is, well, I can take the limit on the top divided by the limit on the bottom. Well, I can't do that. First of all, most importantly, because if I do that, I've got infinity on the top and infinity on the bottom. And that's not a number, right? So when I'm using the limit laws, in the very first thing, it says, assume the limit exists, right? So the limit has to exist. It has to be a finite number for me to use the limit laws. Here, if I've got a bunch of infinities going on, I have to sort of do different things. I have to do a couple little tricks before I can use my limit law in the right way. So, because infinity over infinity doesn't tell me anything, right? So the trick for one of these rational functions, a ratio of polynomials, is you want to look at the highest term overall. So the highest term, is going to be x squared. This is my highest power is 2 that exists in the problem. So then the trick is to divide top and bottom by 1, but 1 of the form 1 over whatever the highest power is. Right? So that's my trick. Now you can see what happens if I pull that in. I'm actually going to write it once like this, just so you guys can see it. But what I'm going to do next is, oops, I lost my 2. Is I am going to simplify those, right? And what I get is this, and it's fine if you go directly from this to this. You don't have to write this guy as a separate step if you understood what you did. I usually will go directly from this to this. I will write down what I'm multiplying by, but then I'll go directly here. So that's fine. Okay. So now, instead of, if I now take the limit of this thing of the top and the limit of the bottom, as x goes to infinity, I'm no longer getting something that's infinity over infinity. All of these limits are now going to a finite number. So now I can use my limit laws because my limit isn't going to infinity. Okay? And so you can see what's going to happen. In fact, I'm just going to write it once this way. So what I'm doing then is I'm now taking the limit of the top, dividing by the limit on the bottom, which now is allowed because I've put my function in a form where I'm not getting infinity, I'm getting a number or 0. Specifically, from what we had on the board here a minute ago, we know that this goes to 0, this goes to 0, this goes to 0, and that goes to 0, right? Fine. So, and as I take the limit as x goes to infinity, the 4 and the 3 don't change. There's no x's there. So what I end up with is indeed 4/3. So the value of this limit is 4/3. If I draw this function, whatever it looks like on the inside, both on the top, on the right-hand side and on the left-hand side, I am going to have a horizontal asymptote of 4/3. if you guys are like, well, I learned that in pre-calc that I just take that coefficient divided by that coefficient, well, now you know why it actually works. It's not just some like crazy thing that they decided that this works. It works for this reason because this is how you can actually evaluate that limit. So I do want to see you evaluating these limits in this way.